Hi, Mr. Murphy here. We're going to be looking at factorising and solving quadratics. We're going to go through a few basics about quadratics, what you should know, and then go into initially factorising quadratics with a coefficient of x squared just being 1, and then go on to the more higher end where the coefficient of x squared will be anything other than 1, so bigger than 1. Okay, so let's start off. The first thing is anytime you're dealing with a quadratic, it will be or should be written in the format where you've got an x squared plus an x term plus so something along them lines. Okay, now the x term sometimes isn't there, so if we're dealing with squared numbers, okay, you may find that the two square numbers, especially if the sign at the constant is negative, okay, the square numbers will cancel themselves out. So if you had something like x squared minus 9 equals 0, when you come to factorize this, we've got no x term and we know that 9 is a square number, so my brackets would have to be x plus 3 and x minus 3. The x plus 3 and minus 3, when we multiply them out, will cancel themselves out, so we lose the x term in the middle, and the 3 times negative 3 will give me my negative 9. Okay, so sometimes you'll see a quadratic that doesn't have an x term. Okay, we know that that's got to be, usually in GCSE, that's got to have a square term attached to it. Okay, whenever you're trying to find it, so for instance, let's look at the one we've just done on the screen. If we then look to solve, we could simply reverse the sign that's on each of those terms inside the bracket. So the inverse of plus is minus and the inverse of minus is plus. So my two solutions on that one would be x equals negative 3 and x equals positive 3. When we've found our solutions, they're commonly also called roots. Okay, so if you see the terminology roots, okay, that means the solutions. So if we've got a graph like that, if it is a positive x squared, it will always be a U-shaped graph. Okay, if it is a negative x squared, it will be an N-shaped graph. The solutions that we've just found, let's say this point over here is negative 3, and this point over here is positive 3. Okay, and we also know from the line equation, the quadratic equation that we've got, that this point down here is going to be negative 9. So that's also going to give me my y-intercept. So straight away we've got two roots, two solutions, and we've got our y-intercept, and that's just in the equation that they give us. Okay, let's get into some more sorts of exam style questions that you could come across. Okay, so this first one, x squared plus x minus 20. We know we've got a minus in the constant at the end, so it means that we've got to have a positive and a negative. So one answer is going to be positive, one answer is going to be negative in my factors. But let's just look at 20. We need to find the factors, the product of two numbers that will times together to make 20, and will sum together and add to make positive 1. Okay, so times to make 20, add together to make positive 1. So, negative 20, sorry. So let's look at the factors. We could have 1 and 20, we could have 2 and 10, we could have 4 and 5. They're all my factors of 20. Okay, so if I'm looking at those numbers, the one that really jumps out straight away is that 5 and 4 potentially are the only two that we are going to be able to make positive 1 with. So thinking about how would I make positive 1 as a sum? Okay, so 5 take away 4 would give me my positive 1. Okay, and 5 times negative 4 would give me my positive negative 20. So we found our factor that we're going to use. We ignore those two pairs and we're going to go with 4 and 5. Whenever you're factorising a quadratic, it will always factorise into two brackets, sets of brackets, because to make x squared, we need x multiplied by x. And we've found our two factors being positive 5 and negative 4. So positive 5, negative 4. My solution for this one is x plus 5 and x minus 4. Okay, and that would give me 2 marks for that question. Right, going on to solve it. We've done the hard part, we've got the factorisation. So we know it's x plus 5 and we know it's x minus 4. And we can move on to the next step by just solving for x. So x plus 5 equals 0 or x minus 4 equals 0. And I'm just going to solve for x by the balancing method. So x equals negative 5. Okay, on this one, get rid of the 4, leave an x on its own, and 0 plus 4 is going to give me positive 4. So my two solutions will be x equals negative 5 or positive 4. Okay. Let's have a look at the next one. If you want to pause the video and have a go, and we'll then go through the answers. Okay, let's have a go through the answers then. So, there's my set of brackets to put it into. To make x squared, remember I need x and x. To make negative 48, so 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. They're all my factors of 48. Okay. The key thing over here is that we need to make positive 2 x, okay, when we sum it. So to make positive 2, let's see which ones are going to do that. Okay, straight away 6 and 8 should be jumping out to you. None of the others will make positive 2 if we try to sum them. Okay. Now the key thing with this is, again, we know that one's positive and one's negative because we've got a negative sign in my expression. But thinking about this, I'm just going to spend 30 seconds just going through this. If we had 6 and 8, the sums we could do is 6 take away 8. We could do 6 add 8. We could do negative 6 take away 8. We could do negative 6 add 8. So we've got 4 possible sums we can do by putting the different signs in different places. So 6 take away 8 is going to give me negative 2. 6 plus 8 is going to give me positive 14. Negative 6 take away 8 is going to give me negative 14. And negative 6 add 8 is going to give me positive 2. The positive 2 is the one that I want. So we can see exactly that way how I'm finding the two numbers that are going to go in my bracket. Minus 6 and positive 8. So my solution, x minus 6, x plus 8. And that gets me my 2 marks. It doesn't matter if the brackets are the other way around. You could put x plus 8 and x negative 6. That's not a problem. Okay, let's move on to the next one. We've done the hard work. We've got x minus 6, x plus 8. Let's make it equal 0. So that means x minus 6 equals 0 or x plus 8 equals 0. And if we solve for both sides, plus 6 for both sides, x is going to equal 6. Take away 8 from both sides, x is going to equal negative 8. Okay. And again, thinking about that, if we look at the where we started and what we end up with, where we started and what we end up with, it's just the inverse sign on the number that was in our bracket. So if you wanted to think about that logically, all you're doing is once you've found the factored version, the factorisation, you're going to do the inverse of it and put it the other side of the equals. So x equals 6. So x is going to equal 6 or minus 8 in this question. Now you might find that some of the questions are written in the context as is on the screen. They've already factorised it for us, and it's a multiple choice question. It's on a non-calculator paper, so we just need to factorize. We just need to solve the factorisation that they've given us. So the second half of what we've just done in the first two questions. So let's look at the first one. So we've got 2x plus 5 equals 0. So if I solve for x, take away 5 from both sides, so 2x equals negative 5, and then divide through by the coefficient of x to leave me x equals minus 5 over 2. So the first one on there is my first answer. Okay, let's look at the next one. We've got 3x minus 4 equals 0. Okay, so 3x minus 4 equals 0. So we're going to get rid of the 4, moving it over to the other side. So 3x equals positive 4. And then we're going to divide through by 3 the coefficient. So it's going to be x equals 4 over 3. Okay, so positive 4, 3. And again, that's the second one. Now, you could think, would I need to do that second step, this one just here? I know I've got 2 to choose from. It's either going to be 3 over 4 or it's going to be 4 over 3. As soon as I know that I'm dividing through by the coefficient, okay, that's going to lead me to that last answer. Okay, have a go at the next one. Pause the video and see how you get on. Exactly the same as what we've just done on the question before. Okay, let's see how you got on. So 5x minus 4 equals 0. So it leaves me 5x equals 4. Divide through by 5. So x is going to give me 4 fifths. Okay, and that's that one there. Second one, 2x plus 3 equals 0. So 2x on its own is going to give me minus 3. Okay, so looking at this one, I know that the negative 2 is going to be wrong. So we know it's going to be that one. So divide through by the coefficient, divide through by 2. Therefore, x is equal to negative 3 over 2. Okay. Okay. Now, sometimes you will get a coefficient of x squared, especially on the higher paper, where the coefficient is greater than 1. Okay, that means that the process is exactly the same. We're still trying to find the product of the constant value, so negative 21, and we're still trying to find the sum of the x term in the middle. But we've got 2 numbers that will factor now. So my 4 is either going to be 1 or 4, 2 and 2, or it's going to be minus, the constant term is going to be 1 and 21, or 3 and 7. They're the only factors. So I've got 4 pairs of factors that I'm looking to think what's going to happen if I multiply them out. Okay, so looking at this, if I did, and again, you can do this if you want to sort of like think about how they would see in the brackets. So let's say we've got 4x plus 1 and x plus 21. So you're imagining what's going to happen in each case. So 4x times x gives me 4x squared. 4x times 21 is going to give me 84x, massively too big. We can see that straight away. We've got x in the middle and we've got 21 there. Okay, so we're really only interested in that center term at this point. Okay, we can see that the 4x and the 1 is going to be too big, and with the 1 and 21 that's not going to go. Okay, so let's try the 1 and 4 again, but this time let's try it with the 3 and 7. So I've got 4x and x, and then I've got 3 and 7. Well, if I want to get negative 21, one of those has got to be negative. Okay, so it's either going to be minus 3 plus 7, or it's going to be plus 3 minus 7. We don't know where that's going to be yet. So, but we do need to get 25. So if we think 4 times 3 gives me 12, 1 times 7 gives me 7, so 12 and 7 gives me 19, that's not going to work. Let's try it the other way around. 4 times 7 is 28, 1 times 3 is 3, and if I take the 3 away, that will give me my 25. So again, at this point, it is just trial and error. So 4 times the 7 gives me 28. 1 times the negative 3 is minus 3. And if I now just work through that and expand it to make sure it fits the original equation. 4x times 7 gives me plus 28x. X times negative 3 gives me negative 3x. And negative 3 times 7 gives me negative 21. Take a 3x away from 28, that's going to give me plus 25x. And I'm happy that that is my original equation. So we've now factorised that fully. If we're now looking to solve, because anytime we have a plus 0 on the end, you're going to need to solve. So we know it's going to be 4x minus 3 and x plus 7 equals 0. So 4x minus 3 equals 0, or x plus 7 equals 0. And again, you can see we're using the same pattern each time, the same process. We're just doing the balancing method. So 4x equals 3. Divide through by the positive coefficient. So that means that x equals 3/4. And on the last one, we've only got 1x plus 7. So all we need to do is take the x away, or x equals 7. So we've got our two solutions down there. Okay, the coefficient that is bigger than 1 is slightly more difficult to do, but if you're logical and you go through the different processes that we've done on the screen, you'll soon get to the hang of it. Now, another type of question, quite a wordy question you may get, is something like this, where they're giving you two line equations. One is a curved, one is a quadratic, and the second one is a straightforward linear line equation, straight line equation. Okay, so we need to find both the x coordinate and the y coordinate to find exactly one point of intersection where the two lines cross. So when they cross on the graph, we want that one point of intersection. Now, you can see in the two equations, we've got two variables. We've got an x variable, we've got a y variable, and we can't solve anything if we need to find two things that we don't know, two variables we don't know. So we need to just try and make it so there's only one unknown. And you can see they both are equal to y. Both equations equal y. So what that does mean is they actually equal each other. They both equal y. So we could then put them to equal each other and find the x variable. So that's our first step. So 9x squared plus 14x plus 7 is going to be equal to 2x plus 3. So we've taken two equations and we've simplified it into one. Next step. Can we get all of the x variables and the constant numbers across to the other side of the equation to make it equal 0, as we would expect in a quadratic equation? Well, to do that, we're going to need to subtract 2x from both sides. And we're also then going to need to subtract 3 from both sides, which is going to give me 9x squared plus 12x plus 4 equals 0. So again, we've just simplified it that little bit further. Next, we're trying to now find and do what we did in the last question. So we're finding the equation that gives us the factors of 4 1 and 4, 2 and 2. We're going to try and find the factors of 9, 1 and 9, 3 and 3. Again, it leaves us with 4 different pairs of factors. And we want to make 12 in our centre x term. So if we look at this, if we did 9 times 1 and 1 times 4, that's going to give me 13. That's not going to work. 9 times 2 is 18. 1 times 2 is 20. That's not going to work. Okay, we can see all of these terms are also positive. So there are no negatives to think about in this one. So 1 and 9 doesn't work with either 1 and 4 or 2 and 2. So let's look at the next one. 3 times 4 is 12. 3 times 1 is 3. Add that together gives me 15. So that's not going to work. So it leaves us with 3 times 2, 6. 3 times 2, 6. Add it together gives me my 12x. So let's write it out in full. 3x plus 2. 3x plus 2. And if I just confirm that is the case, 3 times 3 gives me 9x squared. 3 times 2 gives me positive 6x. 3 times 2 gives me positive 6x. Oops. Positive 6x. And 2 times 2 gives me positive 4. Middle term being 12x. So I'm happy that that works. We've factorised that. It does also help. Remember, there's one point of intersection. So we've actually just got one solution because both of these are the same value. So let's solve for x then. We've got 3x plus 2 equals 0. So substitute the 2 from both sides. 3x equals negative 2. Okay. And then divide by the coefficient gives me negative 2/3. So my x coordinate we can see is negative 2/3. Okay. If you want to pause the video to get that down, I'm just going to erase the right hand side of the screen, give us a bit more space. Remember, we've got our x coordinate, but now what we need to do is we need to find our y coordinate. All we're going to do by finding our y coordinate is find y. We're going to take the line equation 2x plus 3 and we're going to substitute in the x coordinate that we've already found, minus 2/3. So y equals 2 lots of minus 2/3 plus 3. 2/3 times 2, negative 2/3, is going to give me negative 4/3. So we've done that first part, and then we're going to just have to add the 3 onto negative 4/3. Now, to think about that, if I start in a negative and I'm adding a positive to it, some people do get mixed up when they do that part. So there's nothing stopping us rearranging this and saying, if I start with a negative and I add a bigger value to it, it's still going to remain a positive. So if I change that to say 3 minus 4/3, okay, I'm going to get my solution, which is going to give me 1 and 2/3. We've got our 1 and 2/3, so my coordinate for the point of intersection is negative 2/3 by 1 and 2/3. Okay, and that would be my coordinate. Okay, so slightly a little bit more in depth. We're trying to, it's not telling me that I've got to make the two equations equal each other. Okay, I've got to know that I'm doing that. It's not telling me that I need to factorize it. It's not telling me I need to solve it. It's just telling me that show that they have one point of intersection. So I'm just using all of my tools in the toolbox in relation to quadratics, getting it to equal 0 so I can factorize it and work it through from there. I'm going to leave it at that, guys, and I'll see you in the next video. See you later.